Okay, we've gone ahead and installed a Category 5 leaf spring on this particular vehicle, and what I wanted to show you is we actually run a double bearing system in our leaf spring, and we have a lot of guys give us a call on when they do the installation because they see what's going on. I'm going to show you what the leaf spring is going to be allowed to do. The leaf spring, because we run a double bearing, is going to be allowed to tilt. And you can see how this action is tilting, okay? We want that to take place. Now you're thinking, because that you see this angle here, that the differential is going to be moving side to side. It actually doesn't, because when you bolt the other side to it, we're running a parallel link. And then the bushings in the frame don't allow lateral movement. The bearings will not move laterally. They work on a center line. So when this is actually bolted together, we're going to demonstrate how this differential goes up and down, but it's going to be allowed to tilt, not side to side. In a racing environment, that's what you want. The problem with leaf springs is that they're a rising rate rear. When you run performance bushings in the back, as a spring in a straight up and down application is not so much a problem, but when it goes through a turn, it actually starts to increase in rate because the leaf spring is trying to twist, and that increases the spring rate. That's why in these particular vehicles, because they're so soft in the rear, that's why we don't run a rear sway bar, because the rear sway bar actually increases the stiffness even more, which causes an oversteer condition. Leaf spring's got a bad name, you know, for that application because they're not noted for hooking up on corner exit, but you can fix that with these Category 5s. And the main reason why we can do that is because this spring is allowed to tilt, it's not increasing in rate. The same rate's going to be a linear rate now. So in a road racing environment, this actually softens the rear, even though the spring rate is still the same. The car is seeing a softer rear suspension. Alright, so we've gone ahead and assembled both sides. The leaf springs are now hooked. Everything's bolted down. So I want to demonstrate that lateral movement. You know, remember how the leaves were moving? Nothing is moving. It doesn't go lateral. It can't. But let me show you now what it can do, which it never could do before. Okay, so for you guys that have worked on leaf spring cars before, whether you got stock rubber bushings or urethane or even our performance bushings, which we use for our autocross, you know, cars and drag racing, when you pick up on a leaf spring car on one side, you'll notice that the other side will go up pretty much the same time. They don't really tilt, it just goes up. So watch what happens now with the angle when we do this to simulate the car possibly going over a bump on this side. Notice the other side stays and this side's still going up. Well, you can't do that in a normal program. What this does is this makes the rear end plant when you're going around turns, going over bumps, coming out of the corners. It allows the tires to stay flat on the pavement. It almost acts like an independent rear, but it's not. It allows the suspension to work. This Cat 5 system we have is normally used in a road racing environment. It is excellent for autocross as well. Guys with high-end street cars can run this. You can run it pretty much anywhere. But it was originally designed for cars that are running high-end. So you get an idea what we're looking at here. These are all Category 5s. This system that we operate on, called Cat 5, we've been doing it since the early 80s. This is not something new. We make them for Chevys and Fords. A lot of the vintage guys are all on our stuff. Maybe it's the best kept secret, I don't know, but I'll tell you what, this is how you get it done.